Hello, welcome to another lesson in Algebra 1. Today we are covering section 7.4, solving linear systems by multiplying first. So this is our second day on the elimination method. Okay, and this will give us the full elimination method, so we'll learn how to solve any linear system using the elimination method. All right, so your warm-up was to solve each system by either substitution or elimination method, and yes, sometimes one is easier than the other. Okay, so in number one, the x's, the y's, the equals, and the constant terms are all lined up. And when that happens, I always use the elimination method. It's quite easy. And in this case, if we add the system, the y's will cancel out, and that's because the y's are opposites of each other. So we're going to do adding. X plus 3x is 4x. 2y plus negative 2y is 0, so I won't write the 0. And then 7 plus 7 is 14. Okay. Then we're going to divide both sides by 4 to figure out what x is. So 14 divided by 4 is 3.5. And it's okay to have a decimal. All right, now we plug back into either one. So I'm going to plug into the first equation. So I'll say 3.5 plus 2y equals 7. Then I'll subtract 3.5 to both sides. So I'm going to get 2y equals 3.5. And then I'll divide 3.5 by 2 to find out what y is. So y in this case will be 1.75. So our final answer is 3.5 comma 1.75. Okay, so there's the ordered pair where these two lines would cross, and that's the ordered pair that is a solution to both of those lines, therefore it's a solution to the system. All right, number two, let's see, y is already solved for, so this is a great time to do substitution method, and as a matter of fact, we actually know the answer for y already, so I know my answer is something 2. So all I need to do, I can skip step 1, y is already solved for. Okay, step 2 I just do, and I'll just plug in here for y, and what I'm plugging in for is really nice because I just put a 2 there, and what I was really doing was step 3 when I'm just getting the other variable. Okay, so 2x equals 12, divide by 2, and we get x is 6. So 6, 2 is the answer for our solution. Notice if I plug 2 in for y into the first equation, it says 2 equals 2, so that works fine. And in the second equation, it would say 12 minus 6 on the left side, and 12 minus 6 is 6, which is the same as the right side. So it does check. Our solution does not always, one of our equations does not always have to have an x and y for us to find it. Okay, so that's just a horizontal line. And the place where this line crosses it is at 6, 2. All right, number 3 would be a great case to use elimination method if we knew how to do it when the numbers, the coefficients were not the same or not opposites of each other. So in this case, we have to do the substitution method. And the easiest one to use is the first equation and solve for y. And that's because the coefficient of y is positive 1. So step 1, I'll take 2x plus y equals 6. I'll subtract 2x from both sides. And now I've isolated y on the left side of the equation. Step 2, I'm going to take this guy, plug it into equation 2. So in place of my y in equation 2, I'm going to put negative 2x plus 6. And we still have equals negative 12. And then I'll solve this equation. So this is 6x plus 4x minus 12 equals negative 12. And then I'll combine my x's to get 10x minus 12 is negative 12. When I add 12 to both sides, I get 10x is 0. And then I divide by 10 and I find out that x is 0. All right, so for step 3, I plug it back in to either one. So I'll plug it into the first one. So that's 2 times 0 plus y equals 6. So 0 plus y is 6, and that means y is 6. So the solution to this system is 0, 6. Remember, our solution is always an ordered pair, so make sure you write down the ordered pair. Okay, our last part here on the front was not part of the warm-up, so it's a journal. Why is it not possible to solve the warm-up problem number 3 by the adding or subtracting the equations? And that is because the coefficients of x or y are not the same or opposites of each other. So remember, we've only learned how to solve that elimination method when we have examples like this, where the x's are the same or opposites. So here's an example where the x's are opposites, or when the y's are the same, so or opposites. So let me show you an example of that. So in this case, this could be 12x plus 5y equals 10. So here the coefficients are the same, so that works. And here the coefficients are opposites. So we could solve it with adding, subtracting, and these two. But up above in number 3, we had 2 and 6, neither the same or opposite, and we had -1 and +2, also neither the same or opposites. So we can't use that. All right, so let's flip the page and figure out how we could do it anyways. So on our second page, we have solving linear systems by elimination. Most times, a linear system cannot be solved by just adding or subtracting the two equations. However, you can modify one or both of the equations to make it work though. And here's an example. So we have 5x plus 2y equals 16 and 3x minus 4y equals 20. Right now, these coefficients are 5 and 3. So 5 and 3 are neither opposites nor the same of each other. And these coefficients are 2 and -4. 2 and -4 are neither opposites or the same of each other. However, I can modify one of them by just multiplying everything in it by a number. So I picked the first equation. I'm going to times it by 2. And if I do that, I get 10x, 4y, and 32. And I'm not going to change the second equation at all. And now when I look at these, I go, oh, these are opposites. So now I could solve the system. Okay, so the only hard part is thinking of, hey, how do we get some of the numbers to be the same or opposites of each other? And if you're at a loss and you don't see a shortcut to only do it with one, you can always just times one of them by the other. So for instance, if 5 and 3, I want them to be the same. I times the top one by 3 to get 15, and the bottom one by 5 to get 15. So if you times them by each other's coefficient, then it works out every time. Okay, but sometimes it makes the numbers big and there's easier way. It's kind of like finding the common denominator of two fractions. You can always make it harder, but sometimes it's easier if you think of the smallest thing. Okay, add this system to eliminate the y term. So we took the system that we made from above, which is equivalent to our system because this is the same line, just times it by 2, but we times everything by 2, so it's still in the same place. When I add this system now, I get 13x plus 0 equals 52. I solve for x and I find out by dividing both sides by 13, I get 4. And then we substitute that 4 back in for x into either equation. I chose the first equation this time. And I solve for y and I got -2. So my solution is 4 equals 4 comma -2. So this is the ordered pair that works for both. Okay. All right, so let's flip it over and try a couple examples here. So if we look at the first one, we have a couple choices. I could times equation 1 by 2 and leave equation 2 by itself. This would make the x's be the same value. So I'll write that out. So 4x plus 2y equals -18. And the bottom one I wouldn't have to change. This is still 9. And now the x's would be the same. I could have also done this. I could have times the top one by 11. And that would have made 22x plus 11y, and the 11y's would match up right here, okay? I could also have just times the top one by 4 and the bottom one by 2, and that would have worked, okay? So now that I have this, the x's are the same, so I'll solve this with subtraction. 4 minus 4 will make 0x, 2 minus 11 will make -9y, and -18 minus 9 will make -27. I'll divide both sides by -9, and this will give me 3 for y. And then I plug the 3 back into either equation, and I'm going to go with equation 1. So I replace y with 3, and I'll solve the two-step equation. subtract 3 to both sides, and divide by 2. So my final answer here is negative 6, 3. There's the ordered pair that works in both. Okay. All right, number 7. This case, I got to think of the common denominator of either 7 or 5 or 6 and 4. Okay, because I can't just times this one by something, that one by something without making lots of decimals to make them match. So I'm going to use, let's see, let's go with common denominator 7 and 5. So I'll times the top one by 5 and the bottom one by 7. I picked these guys because these are each other's coefficients for the x. Okay, so I times the top one by the second one's x coefficient, and I times the second equation by the top one's x coefficient. And this will give me 35x for both the top and bottom one. Okay, and then on the top one, I do 5 times negative 6y, which will give me negative 30y, and 5 times negative 1, which will give me negative 5. And then I'll do 7 times negative 4y, which gives me 28y, and 7 times 1 for 7. Now you could have also times the top one by 4 and the bottom one by 6, if you wanted to do it that way. Then we can make the y's be the same number. All right. Once my x's are the same number, I'm going to solve this with subtraction. So 35x minus 35x gives me 0x. Negative 30 minus negative 28 gives me negative 2y. Remember, subtracting negative is really adding. And negative 5 minus 7 will give me negative 12. So if I divide by negative 2, I get 6. Okay. I plug the 6 back in for y in either one, and I usually choose the first one. So 6 times 6 equals negative 1. So this is 7x minus 36 is negative 1. I'll add 36 to both sides. This will give me 35. And then divide by 7 for 5. So my final answer is 5, 6. All right. Now our last example, solving these, is a little bit different. So once again, the x's and y's are not all lined up, the equals isn't lined up, and the constant not lined up. So I got to do a little manipulation before I can even start solving. So I'm going to take the second one here, and I'm going to add 7x to both sides. This will give me 7x plus 4y equals, is that negative 8? Yes. Okay. All right. Now I can use these two equations because now I have my x's lined up, my y's lined up, my equals lined up, and my coefficients lined up. And I'm going to go ahead and get the y's to be the same this time. So I'll times the first one by 4 and the bottom one by 3. Okay, that'll be 3 times 4 for 12 on the top and 4 times 3 for 12 on the bottom. All right, so timesing the top one by 4 will give me 8x minus 12y equals 24. And the bottom one times 3 will give me 21x plus 12y equals negative 24. Okay. I'm going to add this system because my y's are opposites of each other. So 8x plus 21x makes 29x. Negative 12 plus positive 12 is 0. And then 24 plus negative 24 gives me 0. Then I'll divide both sides by 29, and I find out that x is 0. Now, just to mix it up a little bit, I'll plug that into the second equation. So let's see, I got 4y equals negative 7 times 0 minus 8. So 4y equals negative 8. Negative 7 times 0 is just 0. And then I'll divide by 4 to both sides to get negative 2 for y. So this is ordered pair 0, negative 2 for our answer. All right, so this concludes learning how to solve any equation using the elimination method. So our trick is just to times one or both of the equations by a constant value so that I get the x's and or the y's to be the same number or the opposite number, so I can use what we learned last time to solve it. And on our last page, you have a warm-up or follow-up here. There are 2 problems. The key is down below, but try them yourself first. See if you can match the key. Please don't come back with my answers written down and no work, though. Okay? I will see you in class, and we'll practice this some more.